Computers understand only one language, that is binary. They don't understand English, they don't understand C, C++. They understand only binary language, which is nothing but 0 and 1, only 2 digits. Now a question naturally arises, why binary? As you know, computer is nothing but is made of electronic devices, right? Electronics means transistors. Everything inside the computer, the processor, is made up of millions of transistors. A lot of transistors are there. And transistors in electronics terminology are nothing but switches. Which perform only two things, on and off. Like on and off are very easy to represent in electronics. And on means 1, off means 0. So it's so simple. Now there arises a small problem here. We humans understand the decimal number system. So we have, let us say for example, a number 123. How do we recognize that it's number 123? There is a 3 in ones place, there is a 2 in tens place, and a 1 in hundreds place. So that is why we say that it's a decimal number system. Why? Because the places are the powers of 10. 10 raised to n, 10 raised to 0, 10 raised to 1, 10 raised to 2, and so on. So we recognize numbers in the powers of 10. On the other hand, we have the binary for the computer, binary system. It is nothing but 2 digits. Why decimal? Because we have 10 digits, 0 to 9. That is why we have powers of 10. Here it's different. We have powers of 2 raised to n. Let's say we have a number 0101. So we have the 1th power of 2, the 2th place, the 4th place, and the 8th place. So this is 2 raised to power 1, this is 2 raised to power 0, this is 2 raised to power 1, this is 2 raised to power 2, and this is 8 is 2 raised to power 3. So this way we have the binary. And if you want to know which number represents 0101 in binary, we have to convert it in decimal, and the process is very simple. This 0 is in 8's place, so 0 into 8, plus this one is in 4th place, so 1 into 4, plus 0 into 2, plus 1 into 1. So this is 0 plus this is 4 plus 0 plus 1. So what is this? Equals to 5. So this number is nothing but 5. 5 is represented like this in binary. Okay, this is all about numbers. How do we represent alphabets? You see alphabets on the screen. So how do we represent alphabets? It's so simple. Let me show you. Alphabets are represented as numbers. Let me write it. Represented as numbers. We have codes for alphabets. A has 65, B has 66, C has 67, and on and on and on. Similarly, for small a we have 97, small b has 98, small c has 99, and so on. So we have for capital and for small letters we have different codes because we represent them as different objects. Small a is different than the capital A, right? So these codes, every symbol is represented in this code. all the symbols you see on your keyboard, even the numbers, sometimes numbers are also represented as codes. So these codes are called as ASCII codes. ASCII, American Standard Code for Information Interchange. It would be better if I write it. American Standard Code for Information Interchange. Right. Numbers done, alphabets done. What about programming languages? How are they represented by the computer? So let's say we have a computer here. My drawing is not so good, so I'll assume that this is a computer. It only understands 0, 1, 0, 1, 1, 0. Only the binary language. It does not understand C++ or C or Java. It does not understand this. So how do we make a computer understand C, C++ or Java? We do nothing but let us say we have the language C. We take it, we convert it to 0, 1s and 0s and 1s, that is binary, and then give it to the computer. So this process of conversion is called compilation. This is called compilation. It is nothing but translation. You translate a language known as C into the binary language. So this is called compilation. Now there are a lot of tools available for this compilation. The first one is known as a compiler. Compiler is there. We also have something called as an interpreter. And the third one is not popular, is an assembler. So these things, these tools which are available, do nothing but conversion from languages like C, Java or C++ to machine languages, means zeros and ones, to the binary language, to the language which the computers understand. These convert the language which we understand to the language which computers understand. Right? So first of all, let us take a compiler. It detects all errors. Apart from converting the program, it detects all errors in that program. In the whole program, it detects errors in the whole program. And it translates the program in the whole. It does not translate it by part by part. Translates whole programs. Then we have the interpreter. It translates line by line. It translates line by line. It does not take the whole program and translate it and give to the computer. It translates it line by line, the first line, second line and third line. It also detects errors, but it can detect errors only in the current line being processed, right? It cannot detect errors in the whole program because it does not translate it as a whole. It translates it line by line. So it detects errors in the current line. And the assembler is for assembly language. It functions very similar to the compiler. It takes the whole program and translates it, but the program is built in assembly language, not high-level languages like C or C++. Okay, now let us look at programming languages. Programming languages. We use programming languages to write programs. We have three types of programming languages. One is machine or low level languages. Machine or low level language. Machine or low level language. Another is assembly or mid level language. Assembly or mid level language. And the third one is problem oriented or high level language. Problem oriented or high level language. So we have three types of programming languages: low level, mid level and high level. The low level language is, let me first partition these three different types of languages so that there is no confusion in between. Okay. Now the low level language or the machine language is the language which is understood by the machine. So it is obviously the binary language. And it is, as it is directly understood by the machine, by the processor, the computer understands only the low level language. It is directly executed. It does not need any conversion because it directly understands it. So it is directly executed. And as it is directly executed, it is very fast. If you write a program in low level languages, it is bound to be run very fast. But we are the people living in the decimal age. So it is difficult to write programs in the binary language. So it is difficult. Okay. Now coming to assembly or middle level languages, which are a level up, a level higher than the low level languages. To remove the complexity of the low level languages, which are quite difficult to understand, these binary languages or these bits, these binary bits are grouped and given meaningful names. Meaningful names. Words, meaningful words like add, if you want to add two numbers, so add, move, moving from one memory to some another memory space, and sub. There are a lot of instructions like these. We don't have to give them in binary. We have to give them in English, which have some meaning. It is easier than the language defined before. It is easier than the machine level language. Easier than machine level language. MLL, machine level languages. Another aspect of the assembly language is that it is machine dependent. There are a lot of processors and lot of computers available in the market. Everyone defines its own assembly language. Like we have Intel, we have AMD, we have the ARM architecture. So these processors have their own assembly languages. Okay, now let's move on to the problem-oriented or high-level languages. The high-level languages are English-like. We have English-like sentences. And as English is very easy language, we are very familiar to English. So the high-level language is very easy to understand. Very easy to understand, to implement, to write programs in. Because we understand English, right? High-level languages are machine independent. Machine independent. Why? Because of the feature called as compilation, which we looked before. Because these high-level languages are compiled, are translated to the low-level language, we can have a translator which translates one high-level language to the machine-level language of Intel processor. We can have another compiler or translator which translates the same high level language to the low level language of another processor, for example AMD. The concept is very similar. For example, you want to translate Hindi to English. What would you do? You would hire an English translator, right? If you want to translate the same Hindi language to Chinese, you hire a Chinese. So the concept is very similar. But the important thing here is that assembly level language or the high level language or the problem oriented language are compiled. Now one more thing remains here is that high level languages are English like. I said that before, but English has some rules, right? Rules for writing, rules for pronunciation, rules for making sentences, right? So these have rules for writing. And these rules for writing are known as syntax and semantics. Syntax deals with the positioning of words, and semantics deals with giving meanings to the sentences. That's all you need to remember at this point of time.